Hello, everyone, and welcome to our webinar, Beyond Hyperscalers, Smarter Infrastructure for Growing Companies. My name is Brandon Wick, and I head up marketing here at NetActuate. Let me start with a few housekeeping items. I want to remind folks that this webinar is being recorded and that the recording will be available once we finish up. There are emails going out to all registrants with the recording, slides, and some supplementary materials. As we go along, please feel free to send your questions in using the question function. There will be a Q&A at the end where we'll try to get to all of those. I'd like to introduce our speaker today, Mark Malla, who's the CEO and Chief Plumber here at NetActuate. Welcome, Mark.
Thank you, Brandon, and welcome everyone, and thank you for joining us today. My name is Mark Malla, and I'm the CEO and Chief Plumber at NetActuate. I've been privileged to spend the last 3 decades connecting people and businesses around the world with networking and infrastructure, and it's exciting to be here with you. Today, we're diving into an important and growing topic: how companies are moving beyond hyperscalers to regain control, cut costs, and get closer to their users. We'll explore cloud repatriation, edge deployments, and smarter hybrid infrastructure options. As Brandon said, we welcome your questions. Please ask them throughout the presentation, and we plan to answer them at the end of the call. I'd like to note that we'll keep this presentation fairly high level, only touching on deeper technical topics briefly, and we'll get into a lot more details in that Q&A. So in this presentation, we're really aiming to give you some ways to think about cloud repatriation that'll help you sort of set the course for your company. So as you read some of these questions, here are some takeaways to consider. Are your workloads still cost effective in the cloud? So you benefited originally, but how many people do you know? This might be true in your own company, might be true of people that you talk to, where cloud spend has just continued to grow year over year endlessly. And I think one of the key questions to ask yourself is that spend growing directionally with your business in some way? And if it isn't, that's sort of a key thing to look at. You should also look at how much visibility and control you have in your environment. Hyperscalers often abstract away control layers that are critical for performance-sensitive or specialized workloads. And have you ever had a production impact and heard from your ops team, it was a cloud, it was AWS, or it was something higher up in the stack? Don't normalize that if that's happening. Another good one is, if cloud costs have become a line item liability. So is your CFO talking about it, your CEO thinking about repatriation? That's a way that you can take sort of stable, heavy workloads and reduce OpEx so you can bring better financial predictability back into your organization. And finally, have you built yourself into a hyperscaler's walled garden? Sadly for us, it's never shocking to start an engagement and learn just how unaware business is of how their stack is architected. It's really easy to include a library in your code and start taking advantage of amazing things. And it's just as easy to lose control of your application and understand, the costs and everything else that goes along with that. So there's a larger conversation around rapid development, organizational development and team dynamics from a product management perspective and an engineering perspective. So how do you balance sort of going fast and being smart? We do have some recommendations later specifically for startups that have cloud credits and how you can best leverage those when you're thinking about repatriation. So we sort of all know this, but why do hyperscalers make sense, or why did they initially make sense? Speed to market, not having to deploy things, not having to manage hardware, being able to scale quickly with capacity, and then offloading a lot of complexity, whether it's security for compliance, whether it's networking, databases or AI. Hyperscalers really let us tap into all of these different tools in a way that didn't require maybe having the employees or resources in-house to manage them. And in many ways, that allowed business to move faster. And the benefits are sort of perfect for early iterations in your company, in your growth cycle, when it's unpredictable, and we understand that. But as you grow over time, you've got to ask yourself, are there asymmetries in that control and that cost? So you're often potentially now overpaying for simplicity. It's not uncommon for us to see, 10x the cost of something on bare metal that's deployed to a cloud service that isn't even really managed. It's just the stack that someone built and they've deployed it. Vendor lock-in is something to think about, performance penalties, egress charges, and then finally, opaque margins, right? Hyperscalers benefit from economies of scale, and they really pass little of that on to you while they're monetizing your data and all the telemetry and everything else in aggregate that you're putting into their stack. So, as cloud vendor profits have soared, your bills have too. Certainly ours have. So that's something to consider. So why look beyond hyperscalers? As we kind of touched on, the first and the easiest reason is cost, which is totally understandable. When hyperscalers know you can't leave, they have no incentive to change the steep premiums they can charge and change at any time. But beyond that, I think let's talk about the issue of control. Your IP, in this case, intellectual property, delivered over your infrastructure. It's the very foundation of your business, and it's your most important strategic asset. It's, in fact, the primary reason your company exists, especially if you're doing business online. So why would you want to be 100% dependent on another company and technology? Building your own infrastructure allows you to own versus rent your infrastructure. And building internally also develops expertise within your company. It empowers employees and enables you to change course in the future as the need arises. Another key thing that you can do is you can performance tune your stack to your needs. So custom infrastructure allows for workload-centric, specific optimizations, latency, throughput, hardware accelerators, and that's a really critical component. Hyperscalers are great. There's 1,000 options when you log in. But do you find yourself in this situation where you're trying to make your business fit into those services instead of the services doing what they should be doing for your business? And finally, one of the biggest things that I really like to talk about and think about is this concept of thinking of infrastructure as a strategic asset. So, move from consuming infrastructure to owning it as a competitive advantage, especially at scale. That's really where we've seen a lot of success with our customers and our partners. So what is cloud repatriation? It's a term that's gained a lot of attention in the past few years, especially as businesses start to evaluate long-term strategies for infrastructure. Major companies like Dropbox, Adobe, 37 Signals, that's the parent Basecamp and Hey, have taken this route. On the 37 Signals note, DHH, the founder of 37 Signals, has an excellent long-running blog series on his own process with repatriation, and he saved his business tens of millions of dollars in OpEx over the last, I think, 4 or 5 years since he started. So I definitely check out that blog if you haven't. It's really interesting to read and follow along. He continues to bring new insights into his journey and how that's impacting their company. So at its core, repatriation means moving workloads fully or partially out of the public cloud environments into their own infrastructure, co-located data centers, or hybrid models that combine private and public elements. Most importantly, it doesn't mean abandoning the cloud. In fact, the most successful repatriation strategies keep targeted workloads in the cloud, and they bring others closer to the edge or to dedicated environments. I would think of it more as architectural refinement, choosing the right tool for each job. Let's break down the main infrastructure models used as cloud alternatives and see how they compare. Colocation, bare metal, and managed IaaS. Colocation is the most hands-on approach. You buy your own hardware, you place it in a global data center, and a third party provides power, cooling, physical security, and network access. This gives you total control over your environment. You can tune for performance, optimize cost, and run proprietary or custom hardware. It's great for high-performance applications or compliance-heavy industries. It also often means that you have to have the staff and the team to manage that hardware, to install it and do everything else. Bare metal gives you dedicated hardware that a third party provisions and manage. You get exclusive access to physical servers, but you don't have to worry about the hardware lifecycle. This is great for companies that want to skip procurement delays. They want to deploy quickly, but they still want sort of the high performance and isolation compared to virtualized cloud instances. Bare metal is also really a way that you can move to having somebody else own the support for hardware in terms of drives failing, memory, and things like that, while you just focus on the stack. Managed IaaS is a good fit if you want to focus on your application and let a third party handle the infrastructure layer. So allow someone else to manage the underlying OS, patching, monitoring, potentially even support services. It's especially true if you're building things in a modern way with containers and using Kubernetes and other types of platforms. Managed IaaS can give you cloud-like agility with the transparency and predictability of dedicated infrastructure. We have a managed IaaS platform that we're calling the Open Network Edge, or ONE. And so in our world, that also means delivering cloud native services that are hyperscaler compatible in a dedicated way. So that includes everything from virtual machines to things like managed Kubernetes, databases, etc. As a company, you can also combine these models across different locations. This is probably the most common use case that we see here at NetActuate. Almost every customer, might have their own data center in some cases. They have colocation in some places. They've got different deployments to hyperscalers. They have bare metal. They have a mix of virtual machines and other SaaS services. So whatever you're doing, you want to be able to mix and match those types of infrastructure across the world, across different regions, so that it makes sense for your business or the technology that you're using. As chief plumber, I'd be remiss if I didn't talk about the importance of the network. I think in this context, what I'd like you to think about is, the network is a critically important asset for all modern companies today. Without a performant, resilient, and cost-effective network, it really doesn't matter how good your underlying infrastructure is. The same thing, today with AI and training, for example, latency may not matter when you're training, but when it comes to actually using that and doing inference at the edge, it matters a great deal. So today there's a big shift from the folks training these large models to actually deploying them around the world. And inference at the edge is, of course, a huge topic. So when you're deployed in a hyperscaler, your network options are often limited, and you're reliant on a shared service that they're providing at scale. One thing I like to ask people is, do you find yourself caching things, using their CDN or using their acceleration services? And if you are, how much are you paying for the privilege of offloading from their networks? Or worse, paying somebody else to save egress costs on your hyperscaler, while you're still overpaying. Just continue to stack margin on top of it. And this one could really be a series in and of itself. But I briefly want to touch on data sovereignty and AI, especially when you're deployed to a hyperscaler. So some questions maybe to ask yourself here are, can you show auditors the city and facility where every data set sits that you have? Do your contracts forbid AI training on your sensitive data, your code, or your customer records? What is the plan if your provider changes its terms? I'll talk about Slack in a minute because they just did that. And does the workload sensitivity justify moving it to owned or partner colocation? It's worth pointing out that many SaaS and hyperscaler terms and conditions are allowing them to use customer data to improve their models for AI training. And similar policies are surfacing in storage, analytics, and of course, generative AI services. Our future increasingly looks to be default opted in to a great data lake. And leading experts say it's only a matter of time before we have a large intellectual property, data privacy issue, or lawsuits. Who knows what's going to happen? For AI to work, right, it needs access to really everything. So the question to ask yourself, we all know how slow and far behind regulation can be. How do you balance the risk of leveraging these technologies with protecting your business and your intellectual property, things that make you special and unique? Slack, which I touched on, recently, I would say in the last year, started doing AI training and offering AI features, and you had to opt out. So you were able to opt out very easily. They did a second round. And to opt out, you had to send a formal legal notice to their legal team to be opted out. So we opted out. In the last week, Slack is now upgrading their plans, and the default plan starts with AI. There's no way to opt out. So as an organization, we have to decide, do we want to keep using Slack or not? I think that's something that's we're going to see more and more of, and it's really key to ask yourself, what would you do? What sort of data are you sharing that you may not want to be? So a real world example of repatriation. This is a SaaS company that we repatriated that had a measurable business impact. They were spending over $200,000 a month in AWS. It's primarily driven by compute heavy CI/CD pipelines. The costs were unpredictable. They were receiving frequent user complaints about latency from the East Coast and other locations, and they were sort of centralized on the West Coast. We collaborated with them to migrate their workloads to co-located infrastructure in our San Jose data center. We gave them dedicated compute with predictable costs and no noisy neighbors. To address the latency issue, we deployed Anycast-enabled infrastructure in other POPs along the East Coast, dramatically improving performance for users in Eastern time zones. The results, so the monthly spend dropped by nearly 50%. The build and deployment times that they were using became more consistent, and their dev teams gained better observability and control. But most importantly, their CFO stopped getting surprise bills. They now have a predictable cost model, better control over their infrastructure, and happier customers on both sides of the country. The second example is a customer who came to us with a very specific goal. They wanted to keep the flexibility of the cloud, but eliminate the spiraling costs they were dealing with. They were spending over $100,000 a month on a cloud native stack, Kubernetes, managed RDS, and all the sort of supporting DevOps tooling. So we stepped in with a fully managed bare metal solution, including Kubernetes on Metal, with a one-to-one service mapping to their cloud architecture, compatible RDS stack that mirrored what they had in the cloud, and a customized DevOps pipeline and even API integrations that were built by our professional services team to allow them to easily shift without having to do a lot of re-engineering work themselves. The best part in this case is that their costs actually dropped from $100,000 a month to just $15,000 a month. We handled all the infrastructure management. Their team was able to keep their cloud-like experience without the cloud-like price tag. And that ultimately gave them the performance, cost efficiency, and control of Metal while still enjoying the ease of use and elasticity that DevOps teams expect from the cloud. All right, so I mentioned this slide earlier. I think that I'll take a little bit more time on this one. It's a very common question, and it's a smart one. You've got $100,000, $500,000 and startup cloud credits. How do you leverage that in Google or AWS or Azure or wherever you are? And I think it's something that you want to be savvy in how you're using those credits and leveraging them until you can make a graceful exit. So a couple of ways that you can do that is to run your own Kubernetes control plane. So avoid relying on managed Kubernetes services like AWS's EKS or AKS in Azure. In fact, the previous case study example that I mentioned, that customer had used an open source tool named KOps to build and deploy their Kubernetes as EC2 instances into AWS. And that was a big part of their ability to very rapidly redeploy into a managed bare metal environment. So giving you a lot of control and building out also like support for multi-cloud use cases from an orchestration layer perspective is really, really important. And as you start to build, make sure that you at least stop and ask yourself these questions as a startup, because once you've started and you find yourself a year, 2 years down the road, you may not be able to, or it may not make sense for you outside of from a financial perspective to try and leave. And even then, that may become impossible. We hear stories of companies that are spending tens of millions in AWS and they simply can't leave because they've so built into those functions. So similarly, you really want to avoid being overly dependent on storage services. So proprietary storage services are things that are highly integrated, but they make it hard to migrate your data. So instead, you can adopt S3 compatible alternatives, and you can stick to open, widely supported databases, ensuring data portability, compliance flexibility, and cost predictability. One of the biggest things I think is and one of the most critical is really keeping your workflow logic portable. So resist the temptation to embed your business logic into the hyperscaler native tooling. So that could be something like Lambda, step functions, or Event Bridge. While these are really powerful services, they create invisible glue code that's hard to extract later. So use containerized workflow engines like Temporal or Argo workflows. They're open, they're auditable, they're environment neutral, and that way you can run them wherever you need, not just in that hyperscaler. You also want to standardize observability on open tools. It's quite common to depend on all the alerting and logging services and things that a cloud environment gives you, and that's very easy in the beginning. But on the back end, when you've grown and you're dealing with thousands, tens of thousands, millions of users, observability can become a huge cost in the hyperscale clouds. So have a plan for how you can do that in a different way. And finally, I think automating infrastructure with portability in mind. So just as you want to keep workflow logic portable, you don't want to use the hyperscalers automation tools. CloudFormation might be a good example, but use open source tools like Terraform or Palomi, and architect your infrastructure as code in a way that abstracts the provider layer. So modularize it, tag it, design it so it can be reused across multiple clouds or regions. It not only speeds up delivery, but it also ensures you retain leverage if you ever need to renegotiate, migrate, or expand. This is a key point that we do see from time to time where you're doing IAC, you're using Terraform, you're standing up a massive AWS environment or a Google environment, but you've not built that little abstraction layer in how you design your Terraform modules and your recipes. And the mistake there is that it could take you weeks, months to re-engineer just the IAC part of what you have to work with another cloud. So from day one, if you start thinking, I want to support multiple technologies, multiple clouds, providers, whatever, build that little layer, that extra 5% of effort, in the beginning when you're a startup, it will save you potentially millions of dollars a year later if you've grown. I will say also that it's quite common to think like if I get to that point, I've got millions of users, I have this gigantic spend, that's a problem. That's a good problem to have that I can go and solve. And I can tell you in a very real way that it isn't. It's 100% possible. We see it all the time to build your stack in a way that you're beholden to these platforms and you can no longer effectively leave because you have millions of customers. They're running, they're operating, they're paying, and your margins are just being eaten into more and more and more. And then the engineering cost and the cost to migrate everything is significant. So final guidance for startup founders is that it's about being pro-strategy. Use credits to accelerate development, but make every design decision with flexibility, control, and long-term business alignment in mind. Really just build above the cloud, not inside of it. That's how you ensure your cloud architecture scales with your business and not just your code. Here at NetActuate, we start all new engagements by seeking to understand your goals. We don't just lift and shift infrastructure. We help evaluate what makes sense to move, what should stay in the cloud, and how to create an architecture that aligns with your business priorities. Our discovery process looks at your current cloud spend, analyzes your traffic patterns, identifies bottlenecks, and helps you decide which workloads are good candidates to bring in-house or move to edge environments. After that, we look at the design. We work with your team to architect a hybrid infrastructure that meets performance, cost, and compliance need. That could involve a mix of colocation, bare metal, any CaaS services. Our architecture team works with our professional services team, often customizing APIs and deploying cloud-native, hyperscale-compatible services to reduce the burden of migration. And then we move into development testing. Our engineering team handles the provisioning, configuration, and optimization of your services. We set up monitoring, logging, and incident response plans. And finally, it's one of the most important things that I say all the time, is that building is one thing, right? It's easy to go deploy infrastructure, even around the world. But running and operating it 24 hours a day, 7 days a week, 365 days is another. And that's where we support and we scale with you. So your infrastructure grows as your business does. In fact, we just had a customer case today where this happened that I can't go into details on here, but we were able to help them very rapidly resolve an issue that they had as they were scaling due to unexpected growth. So we're invested in helping succeed. There are a lot of infrastructure providers out there. What makes us different is our deep technical foundation and our customer-first mindset. We are engineers first. Many of us have built and scaled global networks and SaaS applications. We understand the challenges of latency, routing, failover, and compliance, not just from a marketing perspective, but because we live them every day. And we always take a consultative approach. When you work with us, you get real people who can troubleshoot any type of issue, who understand your application, who are literally sitting in chat ops, shared channels with you, and often calling you, even at 2 a.m, hey, we see something. There's an impact here, or there might be, what would you like us to do? And we're never going to try to force you into a one-size-fits-all solution. Whether you want your own hardware, you want to lease dedicated machines, or deploy a hybrid model of some type, we're completely flexible. The infrastructure that we deploy adapts to your business, not the other way around. So if you're interested, we have a Speak with an Engineer link on our website, and we'll also include it in our post-webinar materials. I like to say there are no stupid questions. When you love what you do, every day is exciting. We're always interested in understanding how we can enable our customers. So come and talk to us. Show us what you're doing. Ask whatever you want to ask. All right, to wrap up with some of these takeaways, here are the main ideas that I'd like you to get from what I've said. Whether you choose to work with us or another partner, all the principles still apply. Hyperscalers have their place, especially for early stage companies or for workloads that need rapid elasticity. But as you grow, it's important to ask if those environments still serve your business goals, especially from a cost, control, or performance standpoint. Cloud repatriation is not an all or nothing proposition. Companies have good reasons for choosing the cloud, and clearly some workloads are best run in a cloud environment. Cloud repatriation is a proven strategy to regain control, reduce expenses, and unlock better end user experiences. Often, a hybrid edge-forward approach is the most ideal. Perhaps most importantly, repatriating strategic workloads helps you control and helps you with the ownership of infrastructure to be more agile in your technical and business decision-making. Don't wait until your infrastructure becomes a significant pain point.
All right. Thank you, Mark. Let's switch over into our question and answer session. And the first question is, isn't cloud repatriation just a regression going backwards to on-prem?
That's a great question. Something I think about a lot, having done this for 30 plus years now, sitting in the data centers, seeing the arc of technology from mainframes to virtualization to containerization to serverless and AI now and beyond. I would say no. Cloud repatriation isn't about going backwards. It's about evolving into a more intentional architecture. Initially, the cloud was a fast, flexible path to innovation. But as workloads mature, as your usage patterns stabilize, and cost structures scale out of control, it makes sense to rebalance. So repatriation means owning the right workloads in environments that match their operational and economic profiles, whether that's private cloud, colo, or managed bare metal. It's a forward-looking optimization, not a regression.
All right, next one. What kind of workloads make the most sense to repatriate first?
Ooh, that's another good question. I think you can really say that the ideal candidates are stable, predictable, and resource-intensive workloads as a starting point, right? So think of any sort of long-running compute services, databases with fixed throughput, internal tools, analytics platforms with consistent usage patterns, ML or AI training workloads that maybe don't need real-time scaling. All of those things consume large amounts of CPU, memory, and I/O. And the longer that they run, the more hyperscaler premiums you're going to end up absorbing. Those can often be run at 40 to 70% lower cost on repatriated infrastructure. So that's just the tip of the iceberg. It's a starting point. It's the easiest one. I think you really can get into a lot more detail as you go beyond that. But if you had to pick, those are the ones that I would start with.
Okay. Next up, let's see what they wrote. We've heavily adopted cloud native services like Lambda and BigQuery. How realistic would repatriation be for us?
That's another great question, especially talking about the services that are easy to integrate into and use in the hyperscalers. So you're not alone. Many businesses find themselves in this situation, right? They make it easy to adopt those deeply integrated services, and that convenience comes with a lock-in. So the path forward there can be a little more complex. Really depends on how you've engineered your stack, and that's something that we would review with our team. But I would say that the strategy probably isn't necessarily a complete break. It's more of a strategic unwinding. So start by evaluating the workloads that can be moved to containers or VM-based alternatives. Introduce a multi-cloud or a hybrid abstraction layer. Look at rewriting non-portable workloads incrementally while retaining critical services in the cloud in the short term. So the key there really isn't overnight migration, but restoring optionality and control over time.
All right. This all sounds like some interesting concepts, but how do I frame this to my CFO and board in financial terms?
Yeah, getting down to brass tacks, right? The dollars and cents. Great question. So I would frame repatriation as sort of a margin reclamation strategy. Cloud costs are often one of the top 3 IT expenses in growth stage and enterprise businesses, and a major contributor to reduced EBITDA. So if you're talking to your CFO, talk to your CFO in terms of the cost per workload hour versus sort of on-premise or colo equivalents. Predictable versus unpredictable costs, right? Repatriation allows for CapEx or for fixed price contracts, something that the hyperscalers say you can have with their MSAs and multi-year agreements and discount tiers and et cetera, et cetera, et cetera. But it's really not true when at the end of the day, when you're looking at these bills and you're looking at the costs, it just isn't true. Leverage and renegotiation, right? So building more alternatives for your business improves your pricing power. It's just the bottom line. And finally, I think that there's a valuation impact that you can talk about with your CFO and board and executive team. And that's that investors are going to reward businesses with sustainable gross margins and operational control. So maybe put simply, every dollar that you save on infrastructure, it directly adds to the bottom line.
All right. And we've got about 5 more here. We're worried about losing innovation speed by moving away from the cloud. How can we stay agile?
Yeah, that's a great question. I would say that in our world, repatriation doesn't mean abandoning agility at all. In fact, it's about choosing the right platform for the right purpose. So, using cloud for bursty traffic or experimental workloads, or maybe you have to meet your customers there and have an extension into a cloud platform. You want to keep hyperscalers in your toolbox for innovation. You just don't want them to be your only dependency. Adopt the right DevOps tooling, the right pipelines, the right container orchestration, so that your repatriated infrastructure is just as programmable and fast as the cloud. I would say often it's even faster. Again, this isn't a technical presentation, but if you've tried to run a large playbook against infrastructure in any hyperscaler cloud, it can take hours, right? It isn't necessarily fast in the way that it can be. And so going back to the one size fits all approach, there's nothing wrong with having product management and building features and getting customers to buy things. But as a company that you yourself are providing services to your end users, if you can customize that infrastructure specifically for your stack, for your business, for your technology set, you're actually ultimately going to go a lot faster than you can in the cloud if you do it in the right way. So all that is to say, though, the goal really isn't less cloud. It's more control with cloud-like speed without the cost or risk of one size fits all sort of pricing and architecture.
Okay. What additional skills, if any, does my DevOps team need to move out of a hyperscaler and into bare metal?
I think there are a number of ways to answer that question. It's a great question. Obviously understanding cloud native DevOps technologies, you want your DevOps team to be using open versions of those things. I touched on it a little bit earlier, but building in a modular way, it's not uncommon to see tremendous DevOps teams that have really built amazing things, but they missed one critical step in the beginning, and that's that 5% effort to say, I might use another cloud in the future or another infrastructure provider in the future, and let me build that sort of little abstraction layer in my modules, and that can require significant effort. So making sure that you're using open source tooling, that you're thinking about that in the beginning, is really one of the key skills that you want your DevOps team to have and to be considering.
Okay. You mentioned NetActuate's open network edge. How does this contrast with proprietary hyperscaler services?
Yeah, that's a great question. The open network edge is a concept that we are building, and that means something much more than just a network. If I think about it from proprietary hyperscaler services, again, they're building things to keep you locked in, right? They're building services that are sticky, even from a network perspective. And so when you're using a hyperscaler's network, you're really dependent on all the things that they've put in place. And they've put those things in place based on their platform's needs. And ultimately, that can include you broadly, right, from a customer perspective, and that they're providing you with a service. But all of the telemetry, all of the optionality that you have when building and defining that network, they're doing it. You don't really get any insights into it, and you get very little control. For us, the open network edge is a way for you to build your own networks, for you to get the telemetry, for you to have access to the global footprint and the global network that we've built, right? But to be able to run your own services on top of it, and to get the intelligence out of it, so that you can streamline your business, you can tie it into your stack in unique ways, and more. Look forward to maybe a webinar or a whole set of topics around the open network edge as we start to launch more services around it.
All right, last question. In what instances do shorter network latency times make a big difference? Is there a significant end user performance difference between 60 milliseconds and 20 milliseconds RTT?
Yeah, that's a great question. 100%, right? And it depends on what your business is. You'd be surprised. Things like VoIP or even this webinar, in terms of video or 60 milliseconds might actually be okay. It might be completely acceptable. But in others, probably the most talked of is sort of the metric of, not just time to first byte, but, time to page load. And there've been hundreds of studies on e-commerce and, just that extra loading time of your store and what each millisecond can do in terms of, the consumer ultimately completing a transaction. If you're shopping and you're clicking add to cart, and at 60 milliseconds, the page is loading slowly and, you're trying to check out, you may not check out. And so that there's a direct correlation there to revenue loss. When it comes to, more modern technologies, we're talking about inference, we're talking about, the agentic, sort of AI movement, and we're talking about all these real-time services. That's where latency becomes even more important. When you've built at the edge and your stack has to make decisions for the consumer, every single millisecond counts. The other thing I would say in terms of latency to think about is there's network latency, there's infrastructure latency, and there's application latency. So here at NetActuate, one of the things that we really focus on, we focus on all of those things, but ultimately the transaction or the application latency is the most important. And so that can include everything from, encoding a video maybe in the cloud versus offloading that to DPUs or ASICs of some kind, right? And delivering the entire transaction back to the customer. And that's something that is absolutely critical that you want to consider.
All right. Sounds good. I think we're getting close to the end of our allotted time. So I just want to thank everyone who's attending here live. And if you're watching this in the future as the recorded version, feel free to contact us via our website and submit any other questions to us that you might have.
Yeah, thanks, Brandon. It's our first time using BrightTalk. We plan to have a series of webinars. The experience seems great so far. So we look forward to engaging with all of you. As I said, there's no stupid question. Reach out. You can schedule a meeting even with me. Happy to talk.
All right. Thanks a lot, everyone.